This is video 912, and the goal of this video is to write the standard form for an ellipse and to solve problems involving ellipses. So we're continuing with our understanding of ellipses, but with some more challenging problems. The first question gives me a general form of an ellipse. That's what this form is called, this form that you see here. Basically, they just multiplied everything out. We see an x squared and we see a y squared. And in this case, we're being told it's an ellipse. So we want to figure out the standard form because that's going to help us find the answers to these questions. What's the center? Tell me where the vertices are, the foci are, and the endpoints of the minor axis. So in order to do that, we have to complete the square. So it starts with the first step, and that is rearranging and putting the x squared and the x together, and putting the y squared and the y together, because we're going to complete two separate squares here. And the other step is to put all the constants on the right, and it already had 11 on the right, so it's already done that part for us. So now we're going to think of this as two separate squares, because we know the rule, the standard rule is x minus h squared over a squared plus y minus k squared over b squared. So we need to complete the square for x and for y in order to write the rule. So the way we start is the same way we've always done it. We factor out the term, and then we ask ourselves what would have to go in this box to complete the square. And it looks like in this case, remember it's simply dividing this by 2 and then squaring it, and we get 4. So the number 4 needs to be put there, and that would complete the square. That would create a square of x squared, x plus 2 squared. And of course the 4 on the outside. But the question is, what additional number did I add on? It looks like I added on 16 over here that were not originally there. So the difference in this than what we did with the quadratics is we're actually going to put 16 on the other side as well. So we put 16 on over here in this form. We have to put 16 on the other side. We're going to do the same thing with y now. We're going to factor out the 9, and then we're going to ask ourselves what has to go in this box so that I've completed the square. And in this case, it's 1. So I need to add on 1. But it's not just 1, it's actually 9. There's actually 9 more units on the left, so I need to add on 9 on the right. So altogether on the right, I have 11, 16, and 9. That balances out with the stuff on the left. And I have a completed square for y as 9 y minus 1 squared equals, well, all this stuff in the blue box. It looks like it equals 36. So I have a completed square, and I've got one more step to write this as a ellipse, because the final step is it has to equal 1. So I always look to this side and I see I need to divide that by 36. So everything has to be divided by 36. So my rule is going to be, let's see, 4 divided by 36 is going to give me 9 on the bottom. And 9 over 36 over here is going to give me 4 on the bottom. And it equals 1. So I have my general form of my ellipse, my standard form, excuse me. But now I need to answer the question. So I'm going to delete all this work here and start to answer the questions. So the first question is, where is the center? And the center I know is h comma k. So the center is at -2, 1. Careful with your negatives here. The vertices, remember those are the ends of the x-axis, or y-axis, excuse me. But in this case it's x because x is bigger. I want to think of this as 3 squared. So now I'm picturing this ellipse, and it's from the center. It's 3 units on both directions. So that means from the -2, I want to add 3 to get 1. And the other direction, I'm going to subtract 3 from 2 and get -5. Okay? If you're not convinced, draw a graph. See if you can start graphing this parabola that you see here. I'm sorry, this ellipse. It's not a parabola, silly me. Graph that ellipse and see if you can visualize where the vertices are. Sometimes it's hard to do it just with the numbers. The foci, remember that's c squared is going to give me, I'm going to get that by subtracting 9 minus 4, and I get 5. That's equal to c squared. But we want c is equal to square root of 5. So just like the vertices, that means it's square root of 5 from the center. So I go back to the center. It's still going to have a value of 1 because it's on that major axis. So fk will still be 1, but it's going to be negative 2 plus square root of 5 and negative 2 minus square root of 5. Square root of 5 in either direction. That's my foci. Okay, so I have to find the c value. And I should check the decimal, and I should make sure that negative 5 is outside of that number. Negative 2 minus square root of 5. If it's not, then I made a mistake. Those are my foci. Now the last thing is the minor axis. So the minor axis, remember, is going to keep the x constant, but it's going to go up or down 2 in this case, because 4 is 2 squared. So it's going to go up or down 4 because of this value. I'm sorry, 2 because of this value down here. So this value here dictates that it's going to be 2 above 1, so it'll be at 3, and 2 below 1, so it'll be at negative 1. Take a look at the sketch of this graph. Use the graph to help you in finding these numbers. Maybe you make a simple sketch until you get the hang of it. But these are the minor axis endpoints. And those are the answers to those questions. So the one additional step that's new is completing the square. So you'll get some practice with that in class with your assignment. Let's take a look at this next example. So now we're going to look at some real life examples. You're going to see a couple of these with these elliptical domed rooms. And they actually are out there because they're kind of an interesting effect. When you whisper at one focus, another person can hear if they're seated at the other focus. So in this, you see these two little people standing at what apparently is the focus points. So this is only half of the ellipse. The ellipse is here, and it actually goes below as well because it's a elliptical shaped dome. So the floor is kind of the center. It goes through the center, which is right here, of the room, and the floor is actually the major axis. It's actually a plane. So we got to figure out how far away those focus points are. So let's see. We want to think first about what is this equation. So let's see. The major axis is 40 feet wide, but that means that it's 20 feet from the center. So it's 20 feet here. And my minor axis is 10. And remember, the c value, which is the distance to the focus points, c squared is always equal to a squared minus b squared, where a squared is the size of your major axis, so it'll be 20 squared, and b is the size of your minor axis, so in our case it'll be 10, will equal c squared. So now we simply solve, and this will give us the distance to the focus. And we get 300. But that's c squared, so in order to find c, I need to square root both sides. C is equal to the square root of 300, which is approximately 17.3. I think about that and I make sure it makes sense with the picture. So remembering it was 40 feet all the way across, 17 is almost to the edge. So that seems about right, okay, because we know it's going to be towards the edge. So 17.3 feet is your answer to the question. So knowing what they're asking is really important, also understanding this picture. So pay close attention to those particulars when you're trying these real-life problems. So you have 2 checkpoints for this video. So try these, bring in your questions into class and your solutions to